I'm going to show how to copy a metal part and use that copy to generate a file to cut that part with a plasma cutter. The main program here is John Walsh's 2013 Logic Trace CNC DXF program. The metal piece was heavy and ½ inch thick. Because of the thickness, the pen wasn't able to digitize the holes. So what I did there was I traced the holes on the paper underneath the piece, and then I digitized the holes off the paper. As you can see here, the tracing is very simple. It's just a cordless pen. You carefully go along the edge of the piece you're tracing. I used the command combination, line, arc, and tracing. And that was because the piece was quite straight, so the line command worked perfectly. The only place I switched it was around that round radius. That's where I used the trace command. As I've written here, I save my work frequently because this way you can back up and you can redo a part of the diagram. So here I'm going to show tracing out the holes using a fine lead pencil and tracing it onto the paper at the background. Once that's done, then I go back to the program and I use the command circle, and all I do is touch 3 points on that pencil drawn circle. When I draw holes, I use a micrometer to check the actual hole, and when the program echoes back and tells me the size of the hole, I either correct it or keep that value. Once I had that paper template done, I just went around and digitized all holes. When I keep talking about the fine lead pencil, I'm saying that because I used a pencil with such a fine lead, I was able to get a good print of the hole. I think if the metal weren't so thick, like say 1/8 inch thick, I think you could do the holes using the pen. But I found with that ½ inch hole, the signal just wasn't being picked up correctly. Once you trace out the holes, you can remove the metal part from the drawing table because the background sheet is still there, and that's accurate to the actual part. Again, simplicity and accuracy is what you're after. The part copying is starting to become finalized. All the holes are done, and once that's done, then we can turn around and save this file as a DXF file. This becomes a standard CAD DXF file. Now I'm going to show 3 programs which can handle this DXF file and create a toolpath and allow you to do some node editing, possibly change the direction of the cut and how the cut is handled. We're going to look at Vectric, Aspire 8.5, SheetCam, and CorelDRAW X8. This short clip here is Vectric Aspire 8.5. It shows how you can bring the file in, how you can edit the nodes, and how you can run it through the simulator and see how the cut will look. This program is normally used for a CNC spindle, not plasma. This next program is CorelDRAW, and you can bring the DXF file into CorelDRAW and you can have a look at the node structure. You can reduce them, or you can add on or change the diagram. Any version of CorelDRAW handles nodes and produces a usable DXF file. This next program is suited to Plasma. This is SheetCam. You bring your DXF file into SheetCam. You can change the direction of how the cut is done. You can edit nodes. You can change the speed. This is a Plasma toolpath producing file. This is the final part of our demo, where I'm going to take the file and have it cut by a plasma operator. It's a tracker plasma, and we used 1/8" steel. I felt for the purpose of this demo I didn't need to use 1/2" thick steel and waste the metal, so I just used 1/8" or 3/16 metal just to show that the size is right on and it was a good cut. I mic'd the holes again, and the holes were right on with the plasma cut to the DXF diagram. So it's a precise, accurate cut. So we went from an original steel part, 1/2" thick, to drawing it out, doing all the holes to the right diameter, and then cutting it. This is the piece that I cut.